we the only ones in the universe? That topic contains a number of other questions. Is Earth the only planet that can host life? Given all the existing real estate, some of it must be occupied. And as mankind throws a bigger net over the universe, catching evidence from millions of worlds, an age-old question plagues us. Is there anybody out there? The good news is that we know far more than past generations. But stick with us until the end of the video to find out which of the habitable planets have been discovered. Some of these topics are more straightforward than others. Our beautiful galaxy is filled with what are known as exoplanets. A sizable proportion of them are little, rocky worlds of comparable size and makeup to our own. A lot of astronomers around the world have been tasked with discovering and analyzing exoplanets that may support life as we know it. Earth-like worlds with protective atmospheres that circle their home star at a safe distance. Based on what we know about exoplanets and planets in our own solar system, other researchers speculate on how extraterrestrial life could differ from Earth-like life. Others hunt for the chemical building blocks of life as we know it in interstellar clouds in order to determine how abundant these materials are across the galaxy. But before we go too far ahead of ourselves, let us explain what exoplanets actually are. To put it simply, exoplanets are planets that orbit around other stars. Essentially, all of the planets in our solar system revolve around the Sun. The word exo is derived from Greek and signifies outside. These worlds are located far, far outside our solar system. Exoplanets are extremely difficult to observe directly using telescopes. The dazzling glare of the stars they orbit obscures them. As a result, astronomers employ alternative methods to identify and study these faraway planets. They look for exoplanets by observing the influence these planets have on the stars around which they orbit. In 1992, the first 2 exoplanets were discovered orbiting pulsars, and around just 3 years later in 1995, they discovered the first exoplanet circling a sun-like star. Prior to such revelations, the presence of planetary systems other than our own had been theorized for decades, and a planet was hailed as Barnard's star in the early 20th century. It later turned out to be spurious. True discoveries were made when technology advanced, which was a relatively recent thing. But how do we go about looking for exoplanets? For decades, scientists have assumed that planets are abundant because the birth of a star is often followed by leftover material, a jumbled residue of gas and dust that might form tiny orbiting worlds. However, finding planets around stars is difficult. It's not as simple as picking up your telescope and aiming it outside. It's not as simple as pulling up your telescope, aiming it towards the sky, and hoping to spot some planets. As mentioned earlier in the video, the orbital bodies are too faint and too close to a dazzling light source. In other words, their sun. Despite these annoying challenges, scientists have discovered extrasolar planets, or planets beyond our solar system that orbit stars other than our sun, by hunting for wobbly stars. A star with planets does not revolve exactly around its core. From a distance, the star appears to be wobbling due to its elliptical orbit. This strategy has led to the discovery of hundreds of planets. However, only massive planets, such as Jupiter or even larger ones, may be observed in this manner. Currently, an additional technique known as the transit method, aka transit photometry, is used to discover exoplanets with even better effectiveness. The transit method was used by NASA's planet-hunting spacecraft, Kepler, to discover the majority of the known exoplanets. This method can discover tiny exoplanets. The transit approach is based on the fact that when an exoplanet passes over the face of its star as seen from Earth, the star's light is partially obstructed and dims. This shift in brightness may be as little as 1%, yet it is visible with contemporary detectors like Kepler's. Only planets far from a high-mass, hotter star can support life. Planets close to a low-mass, cold star can only support life on nearby planets. Obviously, Earth must orbit within the habitable zone of the Sun, yet few planets orbiting other stars resemble Earth very much. They're often way bigger and orbit way too close to their host star than Earth does because those are simpler to detect using any credible observational means. Then, there's the stable rotational axis. Consider how the tilt of the Earth's axis has changed by tens of degrees over 1,000,000 years or more. Without the Earth's more or less consistent obliquity, life may have gone extinct long ago, or it may have never begun at all. But that's not all. It also requires some water, but not too much. Water is the one thing that all life, at least life as we know it, requires. It needs to be more like Earth and less like some of the other water worlds out there. We've searched practically everywhere and we can almost always find the components of terrestrial life: water, materials linked to life, and accessible sources of energy. Now comes the terrible news. We have yet to discover another quote-unquote Earth with sentient life. However, scientists have discovered a few Earth-like planets. So, what are some of these Earth-like planets? Naturally, Earth is the planet that is closest to Earth in terms of being Earth-like. Except in the case of a hypothetical universe with several Earths, this is the only one we have. For scientists looking for additional Earth-like planets, the characteristics of our planet, such as its mass and rockiness, are crucial. Other galaxies might be overflowing with Earth twins. Evidence implies that there might be one Earth-like planet for every 5 Sun-like stars in the Milky Way alone, and discovering non-intelligent life is significantly more plausible. Earth lived throughout the vast majority of its history, 4.25 billion years without a hint of sophisticated life, and human civilization is a late-breaking phenomenon. To start off with the list, we have Gliese 667cc. This exoplanet has at least 4 times the mass of Earth and is just 22 light-years away. Gliese 667cc completes one circle around its host star in just 28 days. But because the star is a red dwarf, much cooler than the Sun, the exoplanet is assumed to be in the habitable zone. Next, we have what is thought to be the closest counterpart to our planet and Sun so far. Kepler 452b is an exoplanet that is only 1,400 light-years away from where you're sitting right now. Despite being 60% bigger in diameter than Earth, Kepler 452b is considered to be rocky and inside the habitable zone of a G-type star comparable to our own. And its parent star, Kepler 452, is 10% larger than the Sun. Kepler 452b orbits its star in just 20 days longer than Earth. Next, we have a whole system that has sparked a lot of attention recently. Maybe due to the JWST. Not only do all 7 exoplanets in the TRAPPIST-1 system seem to be Earth-sized and rocky, but 3 of them are positioned in their star's habitable zone, which is around 40 light-years distant from Earth. On TRAPPIST-1e, F and G, liquid water might hypothetically exist, but the other planets are likely either too close or too far from their Sun to be in this Goldilocks zone. It's also worth noting that, while TRAPPIST-1 contains some exciting possibilities, its planets are not Earth's long-lost siblings. According to some computer modeling studies, even the habitable TRAPPIST-1 planets may have grown like Venus, becoming too hot to host water. TRAPPIST-1e, however, may be the sole planet in the system still suitable for life, but confirmation is difficult without additional evidence. So, all we can do now is wait for the JWST. Let's move a bit closer to home, to Proxima Centauri b, which is only 4 light-years from Earth. It is an exoplanet that circles an M-type star. It has a mass of 1.27 Earths, takes 11.2 days to complete one circle around its star, and is 0.0485 AU away from it. Despite being in the habitable zone of its star, Proxima Centauri, the exoplanet is subjected to intense UV radiation. This is because its proximity to its parent star. So, we are back to the same question. Is there life beyond Earth? We're sorry to announce that the silence has been deafening thus far. While the prospects of discovering life elsewhere are still uncertain, the probabilities are improving. So far, around 5,211 exoplanets have been found. To be honest, the sky is the limit. So, what is the future of Earth-like world hunting? To better forecast the habitability of Earth-like worlds, exoplanet astronomers must first comprehend the atmospheres that surround them. That requires some very strong tools, which happily are on their way.